Hi, everybody. This is the lesson plan for all the conservation of momentum problems and homework and all that good stuff. It should be Friday, January 11th or Monday, January 14th. And appreciate all the good prayers and stuff for me, and hopefully we'll be back for you soon. If you need anything, you feel free to call me on my cell phone. Many of you have my cell phone number, and so if you need passwords to get in the computer or whatever, just give me a call because I'm probably sitting in a hospital waiting room and would enjoy the company. So first thing I want you to do is go ahead and pass up your signed grade sheets that have your semester grades on them. And at any time, if you would, just stop this video, and that way you can collect everything. Once you get everything collected, go ahead and put all that stack of grade sheets right in front of my desktop computer, right next to the TV in the lab. And Victoria during G1 or Shelby during G4 will get those in the grade book for us. So thanks so much for doing that. Once again, you go ahead and stop the video and then restart it when you're ready. The next slide is I want you to staple this cover sheet, which says Career and College Research Project. You're going to staple that cover sheet to your project and get those passed up. I'll come along Friday afternoon or Monday afternoon and make sure I pick those up, and that'll give me something to read over while I'm bored stiff here. And once again, feel free to stop the video. There's a bunch of staplers on my desk with some staples, so if you need to get those stapled, do so. And I'm just going to go ahead and stop the video and start back when you're ready. Okay, the next thing I want you to do is on my desk, right by the camera, should be this answer key that says Chapter 8, Assess. And we're going to go over that homework. So I need you to switch that homework with your neighbor. So please feel free to stop this video at any time to give you time to switch everything. And so I'm looking at page 137 in your book on all these questions. And so the first thing you're going to do is you're going to get 10 points. That's 2 points for each vocabulary word. And so you have vocabulary words of momentum, impulse, law of conservation of momentum, elastic collision, and inelastic collision. It's again 2 points each. Make sure they got 5 of those words. Number 1, it says distinguish between mass and momentum. Well, mass is inertia, but momentum is when you put mass in motion. So you have to have both mass and velocity. Number 2 says which has a greater mass, a heavy truck or a rolling skateboard? It's a heavy truck naturally, but which one has more momentum? It's actually the skateboard because the truck is at rest in this problem. So if you're not moving, you don't have any momentum. Number 3 says distinguish between force and impulse. Well, force is simply a push or a pull, but the impulse is force times time. Number 4 says distinguish between impact and impulse. Well, once again, impact is simply a force, where impulse is force times time. 5 says when the force of an impact of an object is extended in time, does the impulse increase? Yes, it does increase, and that's why we follow through when we swing a baseball bat or a tennis racket or even a bowling ball, anything like that. We follow through to give that force more time on the ball. Number 6, distinguish between impulse and momentum. Well, impulse is force times time, or you could also say that impulse is change in momentum, where momentum is just inertia in motion. Number 7, does impulse equal momentum or change in momentum? It's change in momentum. Number 8, these are going to be good test questions. For a constant force, suppose the duration of impact is doubled. Well, if you have twice as much time, you're going to have double the impact. Number 8A is double. And how much is the resting change in momentum? Well, since impulse is change in momentum, it also doubles. Number 9. Okay, now we're going to number 9. Sorry about that. In a car crash, why is it advantageous for the occupant to extend the time, like with an airbag? Once again, if you have greater time that impulse acts over, you're going to have less force. Now, this is the answer to one of the quiz questions at the end of today's class, because we're going to do these problems, and we're going to do some. We're going to do these questions, and we're going to do some practice problems. You're going to have a little quiz at the end. So number 9 is the answer to one of the quiz problems. How does an airbag work? Well, the way an airbag works is you take the impulse and you extend that over a greater time so you have less force. So make sure you got that one down for the quiz. Number 10, if the time of impact in a collision is extended 4 times, how much does the force impact change? Well, if time goes up by 4, your force is going to go down by 1/4. That's why you want to ride with a punch. If somebody hits you, or if you're a gymnast or a cheerleader that is doing a flip or something, you bend your knees at the very, very end, so you extend the time of impact. Number 11, why is it advantageous for a boxer to ride with a punch? Once again, you have a lot more time, so you have less force, which that impulse acts. And why should he avoid pushing into the oncoming punch? Well, that means there's less time. So less time means there's greater force on the person's face. Number 12, I want you to visualize yourself on a skateboard. When you throw a ball, do you experience an impulse? Well, absolutely. If you throw the ball forward, you're going to impulse backwards. Number B says, do you experience an impulse when you catch a ball? Well, yeah, if you catch a ball, you're going to go backwards. Do you experience an impulse when you catch and throw it? Actually, yes. And part D says which one's the most? It's going to be when you catch it and throw it, because that's just like bouncing. You're going to have one change of momentum when you catch it, and then you'll have another change of momentum when you throw it. Just like the bouncing Shrek ball on the basketball. Why is there more impulse delivered during a collision when bouncing? The change of momentum is greater, so the impulse is greater. In other words, you have to change velocities twice, once to slow down and once to speed back up. 14, the Pelton wheel is the water wheel that had the curved blades, so that when the water went into the blades, it bounced. Once again, bouncing changes the momentum twice, and if you have twice as much momentum change, you're going to have twice as much power. 15, in terms of momentum conservation, why does a cannonball recoil when fired? Well, the cannonball has forward momentum, so the cannon has to have an equal but opposite negative momentum. Once again, when the cannonball's in the cannon, both of those have 0 momentum. So after it's fired, both momentums have to add up to 0. So the forward momentum plus the negative momentum of the cannon go backwards, add up to 0. 16, what does it mean to say momentum's conserved? That you can never, ever change the amount of momentum you have. I don't know why 17's not on here, but it should be on your worksheet. An elastic collision is when energy is conserved and things bounce apart. An inelastic collision is when things stick together. 15, imagine that you're hovering next to the space shuttle out in Earth's orbit, and your buddy has an equal mass to you. So your equal mass buddy is moving at 4 kilometers per hour, and he comes up and just bumps you a little bit. As he bumps you, he holds on to you. Well, if he holds on to you, you're both now connected together. Since you have twice the amount of mass, you're only going to have half the velocity because your momentum has to stay the same. So even though your mass goes up by 2, your velocity will go down to half, so your momentum stays the same. So it's now 2 kilometers per hour. 19, is momentum conserved for colliding objects that move at angles? Yes. In fact, we're going to talk about how to play pool when I get back, and you'll know that 2 balls that hit each other at an angle will always bounce apart at a 90-degree angle if there's no spin on them. So we'll use some strategies for pool in just a second. And then finally, number 20, all the balls have different masses and speeds, and you had to multiply all the numbers together. And so from greatest to least, it's ball B, D, C, and A. And it's the same thing with the impulse. It's B, D, C, and A. 2 points for each one of those. Guys, add all those up, put it out of 70 points, and give them back to their owners so Ms. Phillips can collect them. And then also pass up the answer keys so she can collect those. You can go ahead and stop the video, and then we'll get started for the next part. Okay, in the next part, Ms. Phillips is going to give you some problems to do that are on Chapter 8. And they are going to be 20, let's see, I can't remember what they are right offhand. Hold on, I'm getting there. They're going to be numbers 24 through 27, and then 55 through 62. 24 to 27, this is on page 140. 140 of your book, page 20, number 24 to 27, 55 to 62. I'm going to give you about 20 minutes to a half hour to get these done. Shouldn't take you that long. And then we're going to grade over these. So please stop the video now because the next screen will be the answers. Stop the video now because next screen is going to be the answers. Okay, now what I want you to do is switch your papers now that you're done with these problems. And here are the answers right here. And we'll grade all these real quick. Number 24 is a real easy problem. Momentum equals mass times velocity. So you take the 10 times the 2 and you get 20 kilogram meters per second. 25 is the same thing. You take the 50 times the 4, you get 200 kilogram meters per second. Once again, there's no units for momentum except for the J-dubs. And so you just stick the units together, the kilograms times meters per second. 26 and 27 are impulse problems where you take the force times the time. So you take the 10 newtons times the 2.5 and that gives you 25. But now you combine the N and the seconds together for Newton seconds. 27, same thing. 10 newtons times 5 seconds gives you 50 Newton seconds. 55, down here where you can barely read it, I'm going to take the 1,000 kilograms times the negative 20, because it's, remember, it's final velocity minus initial, so you started at 20 and you ended at 0. So you have a negative impulse of 20,000 meters per second. You can't do part B because they never gave you the time. And unless you know the time, you can't figure out the force. So B is impossible to do. And let's see here. Let me stop it because I can't get to the next question. Okay, 56 gets into a little bit tougher problems. Now you had to combine the two impulse equations together to where you get mass times velocity equals force times time. You put in the 1,000 for mass, the negative 20 for velocity, the 10 seconds for time, and you end up with 2,000 newtons of force. 57 is when you have the little pieces of putty or blobs of something that stick together. So this is just like the lab that we did with the cars that stick together. And you're going to have the mass times velocity of the first blob. I think that's what they are, big blobs. It's something, blobs of putty. Why you would do that, I don't know. And so I'm going to take 1 kilogram of putty times the 10 meters per second, plus the 9 kilogram blob of putty that's just sitting at rest. But at the very, very end, you got to add the two masses together. So the 9 plus the 1 gives you 10, and you figure out the velocity, and that gives you a total of 1 meter per second. And I don't know why, but I just skipped number 57. And that's the one I was doing. I was sitting here reading off number 58. So once again, it's a 2 kilogram blob of putty times 3 meters per second, plus a 2 kilogram blob of putty at rest. And that ends up giving you 4 kilograms. You divide both sides by 4, you get 1.5. If in the part B problem here, the second blob gets bigger. So now you have to divide both sides by 6 and you get 1 meter per second. On 59, you have a bowling ball that ends up hitting a spring. This is a sort of a dumb question. I don't know why you'd ever have that. But the original momentum of the bowling ball is mass times velocity. So 8 times 2 gives you 16. But now the bowling ball bounces on the spring, and they want you to figure out how much total momentum change you have. Well, it's a 16 when it slows down, and then 16 when the spring bounces it back. So you get a total of 32. Once again, you double your momentum when you bounce. And the amount of force that you're going to get from that bowling ball, you're going to take the 32 for the change of momentum. If it all happened in a half of a second, 32 divided by a half gives you 64 newtons. And then 60, 61, and 62 all are using the combined impulse formula of mv equals ft. You're just solving for something different each time. The first one you're solving for mass and you get 1,500 newtons. The next one, 61, you're solving for time and you get 4 seconds. And then the last one you're solving for force and you end up getting, 10 newtons. 10 newtons. So all of that put together gives you a total of, I think it's 90 points for all those problems. So put the number right over 90. Once again, you're going to pass up the answer keys and then pass up the homework, putting all the papers right there in front of my computer, the desktop computer, the desktop computer over there by the TV. Okay, everybody, this is the quiz you're now going to take. And I have the formulas up here at the very, very top. I know I did not write those on your test, so the next screen will show you all the formulas. So when you see the next screen, just stop the video, and that way you can have those up on the projector while you're taking the quiz. This quiz should not take you very long at all. I'm thinking about 10 minutes at the most, and then we'll grade over this, and the class should be about ready to be done. If not, I'll have you watch another little video. But anywho, go ahead and take this quiz. You may not use your notes. You may not use each other. You may not use your books. So this one's all on you. Okay, so please do the best you can. And here are the formulas that you'll need. So you have rho equals mv. Change in rho equals m delta v. Change in rho equals f delta t. M delta v equals f delta t. And then the momentum at the beginning has to equal the momentum at the end. Okay, so keep this up on the screen, but go ahead and stop the video because the next screen you see will be the answer key. Please stop the video now. Okay, and lastly but not leastly, I now need you to switch your quizzes with each other. And Ms. Phillips will now pass out the answer keys to the quiz. It's going to be 30 points. Here's what the answer keys look like. So once again, get those switched. All right, and when you can start the video, when everybody's switched and ready to go. And here's the answer to number one. Write the law of conservation of momentum. It says that momentum cannot be created or destroyed. That's worth 2 points. You could also say it's always constant in an isolated system, either way. Number two, you had to calculate the momentum of a 5.5 kilogram bowling ball going 4.75 meters per second. So you put in the the formula is rho equals mv for 1 point. You put in the 5.5 for 1 point. The 4.75 goes in for velocity for 1 point. And you end up getting 26.125, or a number really close to that. And the units are hard. They're kilogram meters per second. So 5 points for that one. Part 2B says, what's the momentum of the pins? Well, since momentum can't be created or destroyed, the momentum of the pins is going to be the same thing as the momentum of the ball. Okay, so it's 26.125. The next thing you have to do is they give you the force on a golf ball is 1,550 newtons, and it's on a golf ball per 0.65 seconds. What's the impulse? Well, the impulse formula is delta rho, or delta P, equals F times T. So you put in the 1,550 for force, the 0.65 for time, and you get an answer of 1,007.5 Newton seconds. That's worth 5 points. And then lastly but not leastly, it explained how an airbag worked. This is what the answer I gave you at the very beginning of class. So once again, airbags change the impulse. That's worth 2 points for saying that. You have a change in the impulse over a greater time. That's worth 2 points. So you'll lower the force. That's worth 2 points. 6 points total. So once again, you change the impulse over a greater time, lowering the force. And finally, you had to figure out the speed of the bumper car after it got hit. So you're going to use the formula, the MV of car A plus the MV of car B before the collision has to equal MV of the car A after the collision plus MV of car B after the collision. So I'm going to put in the 550 for car A for its mass, the 8.35 for car A for its velocity, plus 425 for the mass of car B, and 0 for its velocity. Well, after the collision, car A stops. So now its velocity turns into 0. And you had to divide everything by 425 to figure out what the final velocity is going to be, and you end up getting 10.8 meters per second. So when you put all that together, you get 30 points. Lastly but not leastly, collect all those answer keys, collect all the papers, and we're just about done. Okay, last but not leastly, if you have 10 minutes left of class, I want you to go to YouTube on this computer here and search Mr. Wright's Momentum Problems page 3. And that'll be the notes. You'll just take the notes. That way you don't have to do it at home. You'll just take the notes for page 3 of the Momentum worksheets. So once again, if you have some time left over, go ahead and do that. Thank y'all so much for your patience today. I'm glad we were able to do this without giving you a bunch of busy work. So have a great weekend. Lauren, hope you had a great weekend if you're a Gold class, and love you guys. Talk to you later. Bye.